Welcome to the DIY Honda Garage Channel. The diagnostic trouble code, DTC P0108, indicates a problem with the manifold absolute pressure map sensor circuit exhibiting high voltage. Specifically, this DTC signifies that the voltage levels returned by the map sensor are higher than expected, usually exceeding 4.49 volts, or an absolute pressure reading above approximately 160 kilopascal. The map sensor plays a crucial role in the engine management system, providing data related to the engine's load conditions to the engine control module, ECM. It is located on the intake manifold, typically connected to the engine via a 3-pin connector. The accurate performance of the map sensor is vital as it directly affects the air-fuel ratio, ignition timing, and overall engine performance. When diagnosing this code, it is recommended to analyze all freeze data and onboard snapshots, as they can help provide context for the error, aiding in comprehensive troubleshooting. The map sensor, which is crucial for measuring manifold pressure, directly influences the performance of the engine by relaying pressure data to the engine control module, ECM. It is typically mounted on the intake manifold, connecting via a 3-pin connector, and consists of a diaphragm that interprets manifold pressure changes. The EDC, or Electronic Control Unit, uses this data to adjust fuel injection timing and ignition, tailoring the engine's performance based on load conditions. The errors indicated by the DTC here suggest potential failures either in the map sensor itself or issues related to wiring, connections, or the ECM. By systematically checking these components, one can identify where the malfunction lies. Thus, knowing the exact layout of the wiring and components aids in accurate troubleshooting. A variety of factors could lead to the triggering of DTC P0108. A faulty map sensor itself is often the primary suspect. It may be unable to provide accurate readings, reflecting erroneous high voltage to the ECM. Wiring issues can also arise, including damage to the wires or miswiring that affects the sensor's communication. Additionally, loose connections at either the map sensor or the ECM could cause intermittent communication disruptions, leading to the map circuit appearing to be in a high voltage state. Furthermore, external factors such as vacuum leaks in the intake manifold can also affect sensor performance. Consequently, a thorough visual inspection of all related harnesses, connectors, and the sensor itself is pivotal in diagnosing and rectifying the problem. Drivers may recognize several symptoms when DTC P0108 is present. Engine performance issues, such as rough idling, decreased acceleration, or unusual engine response may become apparent, as the map sensor directly influences engine timing and fuel delivery. The illumination of the check engine light serves as a clear indication to the driver that a fault needs attention. Another potential symptom is stalling, especially during heavy load situations, where the incorrect air-fuel mixture can disrupt combustion. Additionally, labored engine operation, particularly at higher speeds or loads, might arise, showcasing power reduction. These symptoms emphasize the need for prompt diagnostic inspection once this code is triggered. In the first troubleshooting step for DTC P0108, begin by turning the ignition switch to the on position without starting the engine. This power-on state activates the vehicle's electrical systems and the engine control unit. Then, utilize the Honda Diagnostics System, HDS, to check the map sensor data. The HDS will provide real-time data readings, which should display approximately 160 kilopascal, or about 4.49 volts or more, Observing these readings is crucial as they help validate if the map sensor is functioning correctly or if it is indeed reporting high voltage, which triggered the DTC. If the readings align with expectations, you can proceed to the next troubleshooting step. Conversely, if they do not, check for intermittent failures or connection issues. Should the map sensor readings be below the expected 4.49 volts, it's indicative of an intermittent failure. In this scenario, you must inspect for poor connections and loose terminals, specifically focusing on the map sensor connection and the ECM, or engine control module. A loose or damaged connection could prevent proper signal transmission between the sensor and the ECM, which is critical for accurate voltage readings. Diligently examining the wiring harness for signs of wear, corrosion, or physical damage can often reveal the root cause of the malfunction. Connection quality directly affects the entire map sensor circuit and can resolve the issue if corrected, thus allowing normal function to proceed. Once you've checked the map sensor's connection and ensured that all is well, proceed to the next step by turning the ignition switch to the lock position. This ensures that the electrical systems are shut down safely before proceeding. Next, disconnect the 3P connector from the map sensor. This action is necessary to perform a jumper wire test. This test is vital for isolating the map sensor from the circuit and determining whether the sensor itself is at fault. By managing the electrical connections accurately, we can establish a controlled environment to assess the behavior of the map sensor without any external interference. In this phase of troubleshooting, you will connect terminals number 2 and number 3 of the map sensor 3P connector using a jumper wire. This action effectively bypasses the sensor to facilitate a direct voltage check. Ensure that the jumper wire is properly secured to prevent any disconnections. After establishing the jumper connection, turn the ignition switch back to the on position without starting the engine. This setup prepares the system to allow for real-time voltage reading through the map sensor circuit, helping identify whether high voltage persists when the sensor is removed from the circuit, which is particularly useful for pinpointing the problem accurately. With the jumper wire in place, check the map sensor data again using the HDS. At this point, you're looking for readings approximating 160 kilopascal, or at least 4.49 volts, to indicate that the circuit operates correctly in the absence of the map sensor. Should the readings meet this expectation, you can conclude that the map sensor is faulty and requires replacement. If, however, the readings indicate otherwise, this suggests a deeper problem within the circuit, warranting further investigation as to the ECM's role or other wiring issues. Analyzing this data is pivotal as it drives your next steps effectively towards a resolution. After analyzing the sensor data with the jumper wire, the next step involves removing the wire and measuring the voltage at the map sensor 3P connector terminals. Utilize a multimeter to gauge the voltage between terminals number 1 and number 3 of the connector, specifically checking for a reading of about 5 volts. This voltage represents the reference voltage supplied by the ECM to the map sensor, which is essential for its accurate function. If the voltage is measured at or near this level, the ECM is likely functioning correctly, and attention may then need to shift back to the sensor or its immediate connections. Conversely, if the voltage fails to meet this standard, it suggests an electrical issue associated directly with the ECM or the power supply circuit. Next, the troubleshooting guide instructs turning the ignition switch back to lock, ensuring a safe environment for electrical testing. Subsequently, you should connect the Honda Diagnostics System, HDS, to jump the SCS line, or Service Check Signal line. This process sets the ECM into diagnostic mode, allowing it to self-test and provide real-time error information. After successfully jumping the SCS line, disconnect the 44P connector from the ECM or PCM to further investigate the circuit. This step is critical in isolating potential faults either in the ECM or in the wiring that connects the ECM to the map sensor, allowing for a thorough examination and correct identification of the failure. After addressing the issues related to the map sensor and circuit, it's imperative to perform a final verification. First, clear DTC P0108 from the ECM using the HDS before the test drive. Post-clearance, stabilize the vehicle's operations by taking it for a test drive, letting it undergo diverse driving conditions to monitor for any reoccurring faults. Carefully observe the dashboard for any check engine lights illuminating again during this test phase, which would indicate unresolved issues. Finally, conduct thorough inspections to ensure that all connections were securely made and that wires are intact. A successful outcome would mean no reappearance of the DTC, confirming that the repair was effective. Preventive maintenance is essential for ensuring the long-term functionality of the map sensor and associated systems. Regularly check the map sensor and its connections as part of routine vehicle inspections to catch early signs of wear or looseness. Proper wiring inspections should also be conducted, focusing on areas prone to exposure or damage. Keeping the sensor clean and free of debris will help maintain its performance and reliability. Additionally, ensure the vehicle's software, specifically the engine management system, is regularly updated to align with the manufacturer's specifications, helping avoid potential glitches or errors. This proactive approach can significantly reduce the chances of encountering related trouble codes in the future. In summary, DTC P0108 emphasizes the critical role of the map sensor in the efficient operation of the Honda Civics engine management system. Understanding the functions and troubleshooting procedures associated with this DTC can heighten the effectiveness of vehicle maintenance and repairs. Recognizing symptoms early, such as check engine lights and performance declines, underlines the importance of continuous diagnostic monitoring. Furthermore, establishing a routine maintenance schedule not only prevents incidents of high or erroneous voltage readings, but enhances the overall reliability of vehicle operation. Armed with this information, technicians can ensure the longevity and optimal performance of the engine, leading to a more reliable driving experience for customers. Please like and subscribe to the channel. See you next time.